Is it the definition for the one I just said?
Yes, yes, the one that you just said, dude.
Oh, it's just that acid is a proton donor.
Okay, the proton donor. Alright, but proton donor, then that means that base will be an electron
I think it's just proton acceptor.
acceptor. Okay. Okay. So, okay, so that's one definition of an acid. So what's the second one? The other definition?
So it's like acid is a substance that dissociates with water. I think that produce H plus ions.
Mm-hmm. Mm-hmm. And those H plus ions are similar to what that other definition calls protons.
Yeah, but like just it's just that Broston has
Mm.
like more proof to
Okay.
the
Okay.
definitions and workings.
All right. Okay. 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 That's fine. And then if you wanted to define a base, right?
Yeah.
It instead of H plus, its own is OH
OH
minus, right?
minus, yeah, yes.
Mm. Okay, that's nice. Okay. So you know the meaning of neutralization, right?
Oh yes. Is it now when acid and base is added together?
Mm-hmm. To give us what?
H2O. Uh, carbon dioxide. Uh, is that it?
Primary things that come out when neutralization happens.
Water?
Water is one, yes. The second one.
Carbon dioxide.
So carbon dioxide is optional. It doesn't always come out. But the one that
Okay.
that always comes out is a salt. A salt must come out.
Oh, salt, yes.
Water. Okay. Those are the two that cannot mix. Carbon dioxide is optional. It's found somewhere in the acid, then it will show up, or in the base it will show up. So, so the main things that must show up as products of neutralization are salt and water. So if you look at just you can go back and look at all the reactions that you know about base plus acid, you see that salt and water are constant then on the right hand side. Okay, that's good. Okay, that's nice. So what other questions apart from definition of acid did they ask? Of course, I know they'll give you
Oh
questions that have
yeah. It's
big.
just what we
Mm,
did for the experiments. It's just like how to fill a burette,
mm,
like precautions on how to do them. And they
mm.
also give us like a calculations for like for
Oh,
titrations to solve, yeah.
mm, okay, okay, okay. That's nice. That's good. Okay. Okay, that's fine. So that's basically it for that covered the test, right? That the test covered rather.
Yeah, it was just a page.
Okay.
And he also asked the conjugate base acid. It's just she's just gonna give us like any acid and base, and then just tell us to,
Yeah.
or she can just tell us to like change it to conjugate base or change it to acid. It's just like maybe if it's H O minus, so you just have to like change it to be H2O. You just have to add H plus to it. You have to add acid. So questions like that came up, and then
Okay, that's good. Okay, so one more thing I wanted to ask, as it relates to acids and bases, right?
Yeah.
Um, you know about pH value, right?
pH, pH, yes.
Okay, so there's a range of values on the pH scale that apply to acid. Do you know what that range?
Or is it the 0 to 7 and 7 to 14?
Exactly. Yes.
Alright,
From 0 to 7 applies to acid. Then from 7 to 14 applies to what?
base.
Bases. Okay. And then an exact pH of 7 is for what?
Water neutralization.
Exactly. That's nice. Okay, that's good. Okay. Did you guys talk about litmus paper?
Oh yes, yeah, yeah, to indicate whether it's base or acid.
Okay. All right. So let's talk about it. When it's an acid, what will happen for litmus paper test?
Mm, does it sound like blue or is
Hmm.
red? Because I know it's blue and red.
Yes, yes, it's red. So now that's why you now need to know how to remember it. Okay. So how me I usually remember it, right? Acid usually, well, I don't know how to do it. Alphabet, I'll say acid comes first. Alphabet. So how I usually remember it is, I don't know, maybe it's because my let's call it my favorite color is blue. Okay. So I remember acid, turn blue, red. Okay. But these days I think they just tell you that it's turn litmus
Okay,
paper.
yeah, from blue, red, and then the red just stays red.
Exactly. And then in the case of base, base the will turn the litmus paper blue. So that's just how I know it. So I don't know how you want to remember it, but I remember it that way, it's fine. I just know that okay, blue is the first color, and since acids come before bases, then acids own blue. So it turns to red, or just whatever it is, it turns to red. Then bases turn red to blue, or turn whatever the color is to blue. Okay, all right, that's good. Okay, so um, what I wanted to ask next, is there any aspect of what you might call algebra that you want us to take a quick look at? I have one in my mind, but I don't know if it is something that
What is
we
that?
could start. Indices.
Yeah, indices is fine.
Indices is fine. You want us to look at indices?
Yeah, I understand it, but like I was thinking maybe we should do logs.
Logarithm.
Yes. But my laptop I charged it like overnight, but I didn't know that the socket was not on, so it was low throughout the day in school.
Oh man.
But let me check it.
Okay.
I just use it like that because I've been charging this for years. It's on now.
It's on now.
Yeah, there's part
Okay,
of this log that has word problems.
okay,
The one with EOTB stuff.
okay,
Wow. I'll try send it.
okay. So
Let me just send the these questions. Let me just send the questions first and then I'll send the notes.
okay, all right, no problem.
Yeah.
Let me open my email. Open now. All right, let me stop now. Um, okay. I think that's one. Um, okay, so you want us to look at the all of them, right?
Yeah, I want to check the question because I just said that I'll just check. I'm trying to send some now. So I'll check in a bit to tell you
Okay,
which one to do. Sorry.
okay. Let me share my screen so that you see the one that you sent. Um, this is my screen.
Yes, sir. We can do all question 8 and question 9, just one, and then Okay, let's do question 8, 9, and 11, 12, 13.
Okay.
Yeah, I want to send the. Did you receive the new ones?
Okay, you get some, that is, I think it's still taking time. Yeah. Okay, this one is like you you added more.
Not the one on. Yeah, the one on top. The one above it. This one's. There is more up.
Uh, okay.
Yeah, from that place.
Oh, yeah. So I think in this case, well, most of the time we rely on log tables for our what do you call it? Values for logarithms, right? So yeah. So if we need those values, I think we'll need to use. I guess you would normally use the scientific part of your calculator, isn't it? Not
Yeah,
not a
it's just
scientific.
the same calculator. Yeah, maybe, yeah, some are scientific and some are just.
Okay, okay. The log function. Okay, no problem. All right. So let's see. All right, let's start with all right. So I'll pick on eight. Right? Eight. So the first one is what is the one? But I think it's also like this. I look at it. Okay, so first one, log log x minus y to base b. Log minus y. Okay, first there's a bracket there to show that the logarithm applies to everything. Equals the speed of what? Um, y plus 1.
Unlock.
Yeah. Then next one is uh, two okay. So I think these are like two equations, I think. So we need to solve them. Like it's going to need to list something like this. So let's put it plus 2 to the 3. Uh, that's to the 3. That's y plus 1 and y plus 1. 4, 4. X plus y. Sorry. I know y
Plus
plus
two.
x plus y, but let's just do it and add the question. Add the question. X plus y. Yeah, and all that is equal to 2. Okay. Hmm. How, um, so because of basic laws of logarithm that if I would say they are like a fallout from the laws of indices. So if for instance in indices we are told that for instance x raised to the power of a times x raised to the power of b equal to power of a plus then if we remember that logarithm itself is simply another name for a power to a given base, then that a plus b that I have seen on top are simply two of powers that have been added. So if, like I said, if we understand that another name for logarithm is the power that a number has to a particular base, then that means that A is a logarithm, B is another logarithm. So A plus B on the right hand side will be as good as the sum of two logarithms. So that means log um log of x um, I don't want to make this up now. Okay, log of x times x cubed, right, will be equal to um don't want to make this up, but okay, let me just state the law of logarithm that as I know it. Log x times y plus log of x plus log of y. Okay. Okay. All right. Okay. So you know these rules, right? I just wanted to use it as an example. It's not like I'm going through all of them. You know those basic rules of logarithm, right?
Yes, sir.
Okay. So let's quickly apply it to this question. Um, that first one looks something like it looks something like so it looks something like we are saying two logarithms are equal to each other and they are to the same base. So conceptually, in that sense, you can say that log the base of 3x minus y. If you bring this other guy and what you have y plus 1 equals 0. So now, of course, can infer directly that if multiplication would lead to log of something plus log of the second one, then subtraction would imply division, isn't it?
Yes, sir.
Okay, so this left hand side, I can rewrite it as log to the 3 of since 3x minus y is on the left hand side, it will be on top y plus 1 on the left hand. So all this is equal to what? 0. Okay, so let's complete this thing well. We say the log of something to base 3 is 0. Um, yeah, okay. So how do we interpret it as an indices? Just like you can say the, so let me use a letter down. Log B to base A is equal to C. Then in indices, you can say therefore it means that power base, the power of B to base A is C. So that means that's another way of saying it. So the base is A, the power is C, and the number that owns it is what? B. How we go from logarithm to indices. I don't know if you are familiar with what I just did. Are you familiar with what I
Mm,
just converting from logarithm to indices?
okay.
So think about this thing. And that's why do you agree with me that most math book that you see, in fact, I don't think there's anyone that I've seen that doesn't usually put indices and logarithms in the same chapter. Have you noticed that they usually go together?
Yes, sir.
Okay, so now this thing that I just wrote down now, do you understand it?
But how did do you change, like, why is C to the power?
Okay, good question. So now I want you to listen to how I'm going to read it. I'll try my best to read it as slowly and correctly as possible. Now I'm going to read that left hand side where you have the logarithm. Okay, so just listen to how I'm going to read it. The logarithm, and remember another name for logarithm is power. Okay, so I'm going to first read it as logarithm, then I'll now read it again as power. So just listen to how it will sound. The logarithm of b to base a, that equals to, I'm going to interpret it as is. The logarithm of b to base a is c. Now I'm going to read it again as power. All right. The
Okay.
power of b to base a is c. So did you see anything there? Did you notice anything there? The power of b to base a is c. Now, when somebody is hearing me reading that, you may think that the power should be on b, but no, it's b that owns it, but it's not on b. The power is always on a base, and in this case, the base is a. Okay, so that's why
Okay.
c is a power. Does it make sense now?
Okay.
The power of b to base a is c. The logarithm of b to base a is c. Okay. All right. So that's how it came out like that. Okay. So now we have it like this. You know what I'm going to do next? I'm going to rewrite that document that I booked in terms of indices. So here goes. Remember here It is the logarithm of this guy in the parenthesis, in the bracket, 2 base 3 is 0. So that means we're going to write them like that as they are in parentheses. The logarithm of that 2 base, okay, I'm not done writing it. The logarithm of what I just wrote down now, 2 base 3 is 0. I want you to take a look at it. Does it look similar to what I just did back there with the example that I put there? Logarithm of that whole 3
Okay.
0. You understand it up to that point, right?
Yes, sir.
All right. Okay. Now, as we all know, any number is divided into one. Remember that fact that any number raised to power 0 is 1. So what that is that I am ready to do something like this. 3x minus y over y plus 1 for all this is equal to what? 1. And the good thing is that I can now do what? I can now multiply both sides by y plus 1. So this is what is going to happen so that I have one straight line equation. That makes it easier and better. Okay. So,
Okay.
the aim is just to make it look as simple as possible. So, because I know I've already seen like the continuous equation. That one that they are putting and I can tell it's a continuous equation. So, what will we do now? We'll bring the y to the side where x is so that you know they will sit pretty nicely beside each other. So when this y comes over to this side, it is going to become minus y minus 1. That is minus 2y. And 3x minus 2y equals 1. All these things that we just did now is equation 1. Okay? So we're going to get equation 2 from the second one. That's this. So we just finished dealing with this. We are going to this one gave us equation and other one. So let's take a hand or a look rather at this second one. Let me see if I can put. Can I do this like okay? So this second one, is addition that is there. So we'll interpret it as multiplication. Okay. Now remember, these laws of logarithm are dependent on one fact that the basis of and this case, thank God, all the bases are base 3, base 3, base 3. So we can apply them. So that means that what you have in that second one is actually the same thing as this. Log to base 3 or 2 times x plus 1. Because remember what we said about that law. It's even there. Thank God it's still there. Now, yeah, let's just say it. 2 into x plus y. If you look at the addition law, now the good thing about laws of indices and logarithm is that you can take from the left hand side and move to the right hand side, and you can do vice versa. Go from the right hand side and move to the left hand side. What does that mean? It means that if I see something like this, let me, okay, okay, so you know what I'm talking about. If I see something like this on my left hand side, I can move it, I can interpret it as log x plus log y. And if I see log x plus log y, I can take it back to log x times y. Okay, so that's exactly what I did back here. Okay, you understand what I just did now?
Yes, sir.
Excellent. Okay, don't forget that all this equal to what I already did. This one would have taken as long as possible. I think this one is like a complication of the, the, the length of the other one. So this one is even simpler, or should I say it looks simpler. Okay, so the same thing I did back here, where I said everything of all this to be 3 is what? 2. We can interpret this guy as what? A, as an indices. So here goes. The thing that owns the logarithm are the guys I'm writing down. Are the ones that own the logarithm. The logarithm of 2 is x plus y. 2 base 3 is 2. Please take note. This 2 is this 2. You got that, Abby?
Yes, sir.
Alright, that's good. Why this 3, as you know, is this 3. Alright, so I just thought I should put that there. Okay, so let's see if we can spread this down. 2x plus 2y is even easier. So, sorry, my this thing over here. Okay, 2x plus 2y equals 9. Alright, so can you see how equation came out 9? So that's equation 2. So can solve it. Okay, so equation 1 was what? 3x minus 2y equals 1. So let's put it on there. 3x minus 2y equals what I've done. Yeah. Did you understand what I've done so far?
Yes, sir.
Are you sure?
Yes, sir. It's just the part of the
Mm.
thing, but I think I'm trying to get to it, but
We
I'll
okay,
just
which
go through.
one of the logarithm
I understand the right part. It's just the bottom part of the first one.
okay, the bottom part of the first one. Which side?
Like
This
the
side.
3x equals to 1. Okay, so 3 raised to power 0, anything raised to power 0 will give us.
Uh, 1, yes. So that
Okay.
one I didn't that one doesn't involve anything. Just remember it. Any number raised to power 0 is 1. There's a proof for it. I don't know if I should show you the proof. Maybe that will convince you more. Okay, let me see if I can show you the proof to it. I'll put it beside it so this is the proof I know. I don't know if there's another one that anything raised to power 0 is 1. So for instance now, x, you know the laws of indices that says x raised to the power of a, uh, divided by x raised to the power of a. Okay? You apply the law of indices for division, then it should give me what? X raised to the power of a minus a, isn't it?
Yes, sir.
And a minus a is what? Is it not zero?
Yes.
Good. So that's equal to what? X raised to the power of zero.
0.
Now, let us look at x raised to the power of a, right? Divided by, just do the normal division, x raised to the power of a. Anything divided by itself, will it not give you one?
Yes, sir.
Thank you. So if what if the left hand side of this one same to that left at where I started for this other one that led to x to the power of two, then it can only imply that x to the power of 0 and 1 are exactly the same thing. Did you see that mathematical reasoning I used there?
Yes, sir.
Uh-huh. So this is the only proof me I know. There may be another proof, but well, this is the one me I know. And if I can remember it, God knows, it means that I understood it best. So I don't know if there's any other proof, but if there's any other proof, great, good for them. But this is the one I know, and this is the one I understand. How x to the power of 0 is equal to 1. So what remember is that, that, that just okay. So don't worry, I'll check it. So you go through it again. If you have any questions, you can just send to me via WhatsApp, and it's something that I can explain without us coming to class or before our class. Depending on what you can do. Okay, so are you ready to take on simultaneous equation?
Sir? Hello, sir.
Yes, I said, are you ready to take on the simultaneous equation? Are you ready to solve it?
Yes, sir.
All right. So what will we do in this case? We use your favorite method, elimination method. Which one should we eliminate? Or which one looks like it is ready to be eliminated?
The first one. The 2x and 3x. No, the
You,
2y and 2y.
thank you. And the reason is simple. Both of them have the same coefficients,
Mm,
right?
yes.
Once you understand that, it's easy. Now they have the same coefficients, but guess what? Their signs are different. So should we say equation 2 plus equation 1 or equation 2 minus equation 1?
Mm.
Look at it very well. Should this be equation 2 plus equation 1 or equation 2 minus equation 1?
Equation 2 minus 1.
Okay, so now look at what is going to happen. If you say equation 2 minus equation 1, look at what will happen. You know that there's already a minus on equation 1. By the time I do 2y minus minus y, what do you think will happen? What will minus minus do? Do you remember?
Uh,
It will
is a
become
plus.
so instead of us to eliminate, we're actually increasing it.
Okay.
So that will become 2y plus 2y. That will give us 4y. So, but we want to eliminate. So I don't think minus will be the best option. And if minus will not be the best option, then that means plus will be the best option. You understand now, Abi?
Yes, sir.
Uh-huh. Okay, so let's use plus. So equation 2 plus equation 1. So here goes. Draw your line. Uh, if 2x plus 3x is 5x. Um, 2y plus minus 2y is as good as saying 2y minus 2y because the minus overcomes the plus. So 2y minus 2y is 0, which successfully eliminates y. And 9 plus 1 is what? 10. Okay?
Then
And that means, therefore, x will be equal to what?
2.
2, Abby. 10
Yeah.
divided by 5, which is 2. Okay. So we'll now take x. Now, the good thing about simultaneous equation that I like is that you can put it into any of the equations and get the second one. So anyone, because both of them are 2. So let's put it in equation. Okay, let's put it in equation 2. Equation 2 says 2x. So we just put anywhere we see x, we put 2 plus 2y equals 9. Equals 9. Okay. And 2 times 2 is 4, right? So let's just wonder how things happen at the end of the day. So we know that our subset 4 will go over to the other side to meet 9, and it will become 2y equals 9 minus 4, right?
Yes, sir.
And 9 minus 4 is 5. Okay, so it didn't even give us a whole number. Okay, so that means 2y equals 5. And then we can conclude that therefore y will be equal to 5 over 2, which is 2.5. 2.5 or 2.5, anyone. Okay, so I think that questions like this, they're just asking you to solve it. And solving it means find what x is, find what y is, and then okay. So um do you have any questions about this one? For me, I know that it's not like we can finish all these questions tonight, right? But at least we
Yeah.
can good start. Um we can let me see if we can do one more. Because sometimes when you look at more you look at more you force it in your mind. So look at that second one, right? That second one that says log x squared equals. Don't worry, I'll send you the file to what they work in.
Okay. Okay, sir.
Right. So let's look at that second one. Log x squared is going to the next place. That's the okay. Log x squared equals six. Let me see. I hope I did not leave out something. Okay, good. I did not leave out anything. So whenever there's silence about the base, you treat it as okay. That means they don't care. Well, can leave the base as it is. Usually, sometimes whenever there's silence about the base, they probably want us to just get that go that they are just to understand that they are the same thing. So any number could have been there. Doesn't matter. Any number at all could have been there. So and that's the good thing. So when the base is left out, usually implies that it's not a set. That is why I prefer. Huh? equals 0. Okay, so here goes. We start with the first one that was presented to us. Again, interpret things based on how you see them, right? Um, um, Again, I'll to make it easy, I'll bring bracket of y over to b plus x squared. So this is how my first one will now look, log x squared minus log y. Okay. So remember again, logarithm laws can be interpreted from left to right and from right to left. So this time I'm interpreting from right to left. Which law is that? Division law. So division law says when you have log something over something, it's equal to log the numerator minus log the denominator. So that means that I can interpret it back to where we started from, which is what? Log of the division. So we're taking it back to the division, which means that x squared is the numerator. Don't forget, numerator is always on the left hand side, and y is in the denominator. And all this is still equal to what? 0. Okay, so again, like I said, when they don't tell us a base, well, we can imply that the base is base 10, right? And we have to I have now, because of this, I have to write 10 there, because of what I want to do next. I'm sure you can guess what I want to do next. I want to convert this to what? Indices. Again, how would I read it? I would say the logarithm of x squared over y to base 10 is equal to 0, or is 0. The logarithm of x squared. So you write what owns the logarithm. The logarithm of x squared over y to base 10. You can put your equal sign. To base 10 is 0. And I told you that another name for logarithm is power. So we can read it again. The power of x squared over y to base 10 is 0. So that's what I just did. I just interpreted it. The power always sits on the base. And we all know that anything raised to power 0 is what? 1. So we now have that x squared over y equals 1. And the same thing that we did with that other guy, the denominator, we multiplied both sides by the denominator. Why? So that we would have a straight equation which doesn't have any denominator, because denominators usually we don't like to put denominator. We put x minus y. X squared equals y, sorry, not this. So of course, you know what will happen next? We bring this guy to this side so that we have an equation: x squared minus y
Mm.
equals what? 0.
Mhm.
Do you understand it up to this point?
Yes, sir.
Excellent. That's much. Now you see, the reason why you are more comfortable with seeing this is because you have seen me do it the first time. So now let's go on to the second one now, the second equation. But I've gotten equation one. All I now need to do is to go to equation two. Equation two says that x plus y minus plus k equals 0. So let me do it like I did that one. I'll do them side by side and see if they can arrive at, if they can arrive at the same place. So here we go. So again, whenever you see minus between two logs and they are of the same base, like in this case, implies is 10, then we can transfer it or translate it to division. So again, the guy on the left hand side is the numerator, and the one on the right hand side is the denominator. So then you solve x plus y divided by what? 3. Now put a parenthesis around this so that it doesn't look like the log is on anyone. X what it was. Okay.
Yeah.
All right. Now, same thing I did for that other one. I'll have to put my slide in so that I say the power of x, because by now in your mind, power and logarithm should be the same thing, like I said. The power of 2x plus y, my thing looking like mathematical things look. If you don't somehow if you don't just represent them like that, I don't know whether it happens to you, but sometimes when some things look off, I don't know, it doesn't make me not it may not make me make it, and I assure you it's not just have to say that. Okay. Or do you feel like that sometimes when you write something and it just looks strange on your paper? Have you ever
Yeah.
felt?
Yes, sir.
Okay, okay. I think it's a common thing. People who do mathematics and do a lot of writing. They just the thing looks off. It looks off. Okay, so here we go. To every class over equals same is of of the power of 2x plus y over 3 to the base 10 equals or is 0. That's what happens. So, uh, 1 and x plus y, x plus y. So let me just, uh, okay, okay, let me just try to like this equals 1. And you know what we do to the denominator? Multiply both sides by 3 so that it will become 2x plus y equals 3. Okay, so this will be my equation, what? My equation 2, Abi.
Yes, sir.
Now, we are free to put two of them together. I don't know, do you have an idea of how we solve stuff like this? Simultaneous equation where one of them is an it's a quadratic equation. Have you ever done stuff like this before?
Mm. No, no.
So, okay. So let's look at this guy carefully, right? You can actually do elimination method here too. Yes, you can do elimination method here. Let's go. But then the only thing is that you are limited. Do you understand? You are limited to what you can eliminate here. You cannot eliminate x because one of x is x and the other one is x squared. So that's the problem. You cannot eliminate x. However, you can eliminate y. Can you see that?
Okay, sir.
Okay. All right. Goodness, don't worry. See, I always tell people, you are starting like this, or let me not say starting, or yeah, it's a bit. for this now, but I can assure you, you would be, you know, I don't know how to put it, or you would be in a place of mastery, or with this thing, with a lot of practice. A great deal of practice. So just get comfortable, and I'm sure, you know, I don't want to say nature will take it, but eventually come to grasp it, you eventually come to grasp it well, have a good grasp of it. Okay, so let me ask again. If I wanted to eliminate one, what do you think of it?
Change the sign.
Did you say change the sign?
Yes, sir.
No. When we come to elimination now, we are either doing equation 2 minus equation 1, or equation 2 plus equation 1. So which one should we do?
Mm, equation 2 to 1.
Plus or minus?
Equation 1 to 2, yeah.
Okay. So let me just add it. So equation 2 plus equation 1. So let's see how it's going to come out. Now this one, I want you to look at it carefully. Right? 2x plus x squared. You can write it as x squared plus 2, right?
Yes, sir.
X squared plus 2x. Okay, just write it like this. Then look at the other side where you have plus y plus minus y. Always remember, whenever you have plus minus something, the minus overcomes the plus. So it will become y minus y, which is what? 0. So in other words, y will disappear. And we're left with what? 3 minus 0, which is what? 3. Okay? So now I want you to see how this thing beautifully turned out. Can you see a quadratic equation emerging?
Yeah, correct. Yes, sir.
Uh-huh. So that's very well. A beautiful quadratic equation emerging. And I can even solve it. Sef. We don't need almighty formula to solve this one like this. Okay. So what should we use to solve it? Remember that question we asked ourselves. What are the conditions? Are the conditions met? The condition is that the coefficient of x squared is 1. So has that condition been met? Okay,
Mm,
let me not even
three
assume
plus
that you
one.
know what I'm talking about. Do you know the meaning of that term coefficient?
Yes, sir.
Okay. So the coefficient of x squared, in this case, the requirement is that the power that has squared, the coefficient must be 1. Has that condition been met in this case?
Yes.
It has, exactly, good. It has. Now, what that means is that I can go ahead and ask myself those two questions. What are two numbers such that when I multiply them, I will have minus 3. And when I add them, I will have plus 2. Do you remember those two questions?
Yeah, it's
When I add
multiply.
them, yeah. So what are two numbers? When I multiply them, I have minus 3. When I add them, I have plus 2.
Mm,
Numbers come to your mind. What and what?
One and
One and
is it 1 and 1 or 1 and 2
one
or 1 and 1? Because
and
to
so
multiply 3 and 2.
uh, so okay. So let's think about it. So you know how I usually answer this question. I work on the multiplication part first. What are the numbers when I multiply them that they will give me 3? Technically, it's just 3 and
One
1,
and
isn't it?
three. Yeah.
Now, which of them, which of the combinations, because it has to be either minus 1 times 3 or minus 3 times 1. Do you understand? That's the only thing that will give me minus 3. Minus must be on one of them. Do you agree with that?
Yes, sir.
Good. Now, which of them, which of those two combinations will I add to give me 2? Minus on 3 or
One and
minus on
three.
1 and 1 and minus 3 or 1 or minus 1 and 3? Which one?
Minus one plus three.
Thank you very much. Minus 1 plus 3. Thank you. So that is what we enter the graphic. Let's try this naturally. See how simple this method is. Minus 1 and x plus. So, then, and then you can now and say, put your 0 there. So, there we go. Of course, you know that it means that x equals x. Like, I tell you like following. Uh, anybody who picks up what I've written down and that so means that x forward x equals two. So now, can you see that now that x has two values, automatically y will have two values? Do you agree with that?
Yes, sir.
So let's simply see the values of y. So this one now took a different twist because for that equation, but it's fine as long as we understand what is happening. So if x is equal to 1, then we can now, of course, nobody needs to tell you which of the equations will you like to test that you use it to find the value of y. Like equation 1 or equation.
Mm, equation one.
So for equation 1, equation 1 says x squared minus y equals 0. So that means that 1 squared, 1 squared minus 1 minus y equals 0. So that means we can take y to the other side, and it means therefore 1 squared,
Y.
which is 1,
Yeah.
is equal to what? Y. So this one has solved itself. Y is equal to 1. On this other side, if we put minus 3 there, always remember, whenever minus 1 is repeated, always remember to put everything back. Minus 3 squared minus y equals what? 0.
Yeah.
Okay, and that means that 9 plus 9, which is as good as 9, equals what? 0. And the same thing that happened today to the V value. Therefore, 9, so that 9 equals y, or y equals 9, anyone you like. So, yeah. Okay, so I think I'll let you just go through the talk from here on Saturday. Or let's do it. You know what I will advise? If you
Yeah.
can, try and see if you can do number three. Okay, and if you look at number three has some conditions. X is greater than 0 and y is greater than 0. That means that If they had given us that condition, if I can choose, guess what? That means that we wouldn't have taken this value for x. This value for x would have been out of the picture. Sure, you understand? Would
Yes,
have
sir.
cancelled this. So that's a clue to you for number three. Anytime you see, of course, I'm telling you that there will be negative value for one of them. Ignore the negative value and focus on the positive value. Okay.
Okay, sir.
So, yeah. Maybe we can split to we can number three, do go to number four, then we'll do number three together. Then maybe we'll pick up on
Yes, I sent the other question that I sent later. Should we do the first one?
this one.
Yeah, that.
I all right. May not take this long, but let's just 8 raised to the power of 4, 2 raised to the power of 5x minus 4, 5 divided by square root of 2. Okay. All right. Huh. Solve this one, right? Let's solve this one. This is what I'm doing. I can see that everything here has it, it has a base of 2. You look at it carefully. So what we're going to do is we'll make everything in terms of the I'm going to make it as for and then on the right hand side, I think these ones are already they're already behaving themselves. Okay, the only one is that we have to everything that is so that thing, I hope you know that.
Yes, sir.
Okay, all right. If you forgot, remember it. So anything square root of
Yeah.
anything is simply that power. Okay. So of course you know that law that it was x to the power of all raised to the power of equal to the power of AB. Okay. That is just saying that the power inside will multiply the power outside. So 4 over 3 times 3, you can already see what you have. So 3 on 4, by the time you multiply it by trying my best to write that in a tiny way, but still visible, you will see that the 3 will cancel the 3. Okay? And
Okay.
then we're left with equals to 2 raised to the power of. It looks like nothing is happening on the right hand side one. Very good. So that is okay. 2 raised to the power of half. Okay. So so we're left with what? 2 raised to the power of 4.
4
4.
equals
Yeah.
2.
Yes, what do you think will happen on this right hand side? This is division, right?
Yes, sir.
And it says whenever we have division, the powers will subtract. So that's going to be 2
2,
raised to the power of 5x minus division
3.
half. Okay, all that is equal to 2 raised to the power of 4. Now, there's a principle that says when you have the same thing on the left hand side and on the right hand side, same thing, that what happens, the powers must be the same. I don't like to say cancel. No, we're not canceling. There's nothing is canceling here. Okay, you understand what I'm saying?
Yes, sir.
So it's something cancel something. We're not dividing, we're not multiplying, we're not. So it's not a case of canceling. We're just saying that this implies that whenever there's the same date, this implies that what the
We
power change.
will solve with the
So that means
powers.
4 years, 4 must be equal to what? 5x minus
Minus 3.
minus half. And you know how we don't like to see denominators in our work. So we're going to multiply all the terms by what? Do we really? Okay.
But is
Let's
it
multiply
2?
2. Yes, you're right. Okay, so that means this guy will be 8. 2 times 4 is 8, isn't it? This one will
Yes,
be
sir.
10. This one will be 6. And this one will be 1. So in case you're wondering what I did, let me write it there. Multiply all the terms by 2. Okay? And the 2 is because of that 2 that is there. Now, let me say something here, which I don't know if I've said it before. I know that I've probably taught a few more people different related something in math. Anytime you have a fraction in an equation like this, and you want to simplify that equation, like before you now solve it, if you have only one denominator, in other words, you have only one number denominator, like in this case 2, then multiply all the terms by that 2 or whatever that number is. Now let's pretend, take note of what I said. Let's pretend we have another number, like say 7, right?
Mm.
If you have two numbers and you're now wondering which one should I multiply by, 2 or 7, simply take the LCM of 7 and 2. Why? Because the LCM is what can take out both the 7 and the 2. It is that LCM that you now multiply all the terms by. Did you get that?
Yes, sir.
So let me go back to our original question. Okay, so let's go. You now know what to do, right? Collect like 10. Move the minus 6 minus 1 is minus 7. Move minus 7 to the left hand side to meet the 8. It will become 8 plus 7. 8 plus 7 equals what? 10x. Okay. And then
Mm-hmm.
8 plus 7 is 15, Abi. So
Yes, sir.
I have 15 is equal to 10x. And
Then,
of course, we'll be dividing both sides by what?
mm, by 15? No, by 10.
Thank you very much. You'll be dividing both sides by 10. And
Yeah.
10 is one of the easiest numbers to divide by because all you just need to do is to introduce a decimal point. from the right hand side. You count one place to the right, and that's going to be 1.5 equals n. So it depends. If the question, if the options, if there were options, so and you didn't see 1.5, then you definitely see what? One and a half, right?
Yes, sir.
Anyone that you see slides. Okay, so are you good with that?
Yes, sir.
Okay, all right. So that's okay. So I think we can leave it off here for today, Abby, and then we'll continue on Saturday.
Yes, sir.
Uh, okay. I will say we can continue that one. Okay. So you don't have any outing for Saturday, right?
No, it's the next one.
So let's um by hold on, hold on a minute. Let me check my schedule. Okay. Um uh-huh. Okay. So yeah. Would you be available for 10 a.m. your time on Saturday?
This one
Yeah.
till one.
Okay. We can do 10 to
Sorry, 10 to 12:30 or 12.
10 to 12. Yeah. We can just do 10 to 12.
Okay.
Um, okay. So I'm just trying to use my time because I'm not too sure how power over here will play because these guys have been really messing us up sometimes depending on the timing. But I want to see how, if it's possible, we can do all our classes in the morning. Power. All right. So yeah, that's fine. If you see them. Okay. So remember to try number three, number four of that question for the logarithm after you've
Yeah,
taken a look at it.
I will try to go over it and try to see what happens.
Okay, yeah, yeah, fantastic. Exactly. Okay, then enjoy the rest of your evening and the rest of your week.
Thank you, sir.
You're welcome. All right, have a good night.
You too, sir. Bye bye.